Hey guys, this is Sean with Alexander Tutoring, and today's video is on completing the square, something I'm surprised I haven't done yet. Um, a lot of students have a hard time with completing the square the first time around. A lot of you are probably doing it right about now. I think a lot of the algebra classes are working on quadratics. A quadratic, in case you don't know, is something that follows this format, or a number a times x squared plus some number b times x plus some number c. Okay, so I gave an example one up top here. So I'm comparing the two. We can see in this case that A equals 1, B equals 14, C equals negative 38. Don't forget that minus sign in front, that's important. So you've probably learned how to solve quadratics by factoring, and you've probably seen how to solve quadratics by using the quadratic formula. Well, it turns out there's a third way to do it called completing the square. The first method, factoring, is probably the easiest, but it doesn't always work. Like you can't do it on every quadratic. Whereas completing the square always works, kind of like the quadratic equation. So I'm going to show you how it works. Let's take this guy down here. And what I'm going to do, the first step in completing the square is to get the c term, the number term, to the other side of the equation, and then we're going to concentrate on the x term. So whatever the c term is, in this case it's negative 38, we're going to add 38 to both sides, just to move it to the other side, and then we're going to focus on the left-hand side with the x's. Okay, equals 38. Now, the whole trick with completing the square is we want to add some term here, and of course we have to, whatever it is, we have to add the same term to the other side, because you can't just put it on one side and not the other. And we want to find a number that we can, like a c term, like a number that we can put there, such that the whole left-hand side will factor into a perfect square. So as you recall, kind of the first method you learn of factoring, you're always trying to find two numbers that add to the middle term and multiply to get the last term, and that's, you use those numbers to factor. Hopefully you know what I'm talking about. So what a perfect square means is that you basically get the same number twice. So for example, parentheses x plus 7 close parentheses squared is a perfect square because it's the same thing times itself. Okay, so we want to find a number that gives us a perfect square with x squared plus 14x plus something. And the way we find that is we take the b term, we divide it by 2, and we square it. I'll explain why we do that in a second. For now, just take my word for it, but I promise I'll explain where this comes from. So as we know, b is 14 in this case. So for us, we have 14 over 2 squared equals 7 squared equals 49. Okay, so in theory, 49 is the number that we can add to both sides that will give us a perfect square. Let's try it. So I added 49 to both sides of the equation. And then we want to try and factor the left-hand side. So how do you factor? Again, you want to think of two numbers that add to the middle term and multiply to the c term. So what adds to 14? What two numbers add to 14 and multiply to get 49? Hint, it's always going to be the number in here by design, which is 7. 7 plus 7 is 14. 7 times 7 is 49. In other words, we can factor this guy like that, which is the point, and then 38 plus 49 is 87. Excuse me. Okay, and the whole reason we want to complete the square, or have a perfect square, is so that we can do this. Write it like this. Why? Because now we can solve for x. Before we couldn't. How? Well, we square root both sides, which gets rid of the squared on the left-hand side. And then on the right-hand side, don't forget your plus or minus. Anytime you square root both sides, you got to put that plus or minus in. Okay? Now guess what? We can solve for x. We just subtract 7 for both sides to get x equals negative 7 plus or minus the square root of 87. And that should be your solution. Of course, there's generally two solutions when you have a quadratic, I should say generally. Sometimes you can have one solution. But that's what the plus or minus represents, the two solutions. Okay, now I just want to talk briefly about why we used b over 2 squared to get that term that's going to complete the square, so you don't think that's random. Well, how do we factor things, right? Like, let's do that process backwards. Let's say we started with x squared plus 14x plus 49. And our job was to factor that using the factoring, kind of initial factoring technique that I assume you know, which is we want to think of two numbers that add to get the middle term and multiply to get the last term. Well, if we take that, and that's 7 and 7, right? So here, let me just factor this. So we already know that's 7. And you recall factoring is like foiling backwards. So let's look at the FOIL part. What if I expand this back out? How do we do that? We do x times x is x squared. X times 7 is plus 7x. X times 7 is plus 7x. And then 7 times 7 is 49. So do you see that process there? Do you see how when we were foiling it out, the 7x and the 7x, they added to get the middle term, or 14. And then the c term, we had 7 times 7 to get 49. So those two numbers multiplied to get 49. And so a way you can always get the number that works, it's basically the reverse of this process, right? Like we need a number that adds to 14, which is the same number. So it's always going to be divided by 2, right? If we're trying to get a perfect square, we can just simply divide the middle term by 2, right? 14 divided by 2 is 7, because 7x plus 7x is 14x. And then the reason we square it and add that to the end is because that gives you that last term, the 7 times 7, right? So b over 2 squared by design gives you that perfect square. And again, it's kind of, when you see the foiling process, which you should be familiar with, that kind of illuminates why that rule is the way it is. Anyway, I hope this helps you a whole bunch with completing the square. Thank you for watching.